Hey there, welcome, and I'm Rowan, and today let's see a small data science project. I'll be explaining you about the prediction of Titanic dataset. Titanic dataset is a very famous dataset. As for beginners, it's the best dataset to work on. So let's see how we can proceed with the EDA and all those things, and I'll be explaining you step by step the process. And please, you can find the link in the description for this project. Let's begin. Start. Here we have taken Titanic Survival Prediction dataset, okay, and this whole project is done in Jupyter Notebook. You can do it in various platforms, but I prefer Jupyter Notebook because majority of them use Jupyter Notebook. Okay, so these are the points which we are going to discuss today. Okay, so don't worry about this last point, but then this is the very important point. Till year from 1 to 6 is a very important models. Okay, so let's start about necessary library files. Okay, so these are the very important library files. With these library files you can do anything possible in analysis and data science. Okay, NumPy is used for working with arrays, and pandas is used for data analysis. This is a data analysis library. Pandas is very famous for analysis and even data science. So matplotlib, this is used for data visualization. This is used for advanced visualization. Seaborn, you can do many things. It's too much graphics, and this visualization is so easy in this. And then warnings, and especially this module warnings, we have used this for ignoring the known warnings. Okay, errors or something which will be known to us, and we just don't want it to show. So we use this libraries to ignore. Okay, so let's read the data. So we are using pandas, and we are using this train to store this values in the train by using pandas.read CSV. Okay, this is a CSV file, comma separated value file. That's why I used read CSV. If it's Excel, I'll use Excel. And train, this is the actual thing which, for example, if you are doing it in your system, you can use either this one, or if you're doing it in Jupyter, you can use just train.csv. If you're taking the data from a different location of your file, you can use this. I've used R because I'm using Windows, and if you're using Apple, please don't use R. Okay, and fine, the test data I've taken into this, and train data I've taken into this, and then this is a description of test data. Okay, so here describe gives us all the descriptions. Okay, one second, there is a lot of small error. PD is not defined. Yeah, fine. So don't forget to run everything. Okay, it should be in order. See, without running this, I try to run this one and this in error. Fine, this star shows running. See, this is the first time running in this machine, so it takes some time. Let's not worry about it. Okay, so here we get the data. Okay, so this is the columns. We can see so many columns here, and this is not the data, guys. This is in this row. You can see that this value is 891. There are 891 data. Okay, passengers data, and survived. This is the percentage of survived, and mean is nothing but average. Okay, in statistic we use it as mean. Standard deviation, minimum value 0 and maximum is 1. That means 0 is dead, 1 is alive. Okay, survived and didn't survive. And passenger class, first class, second class, and third class. Third class is the highest. Okay, so first class will be something like a premium one, and third class will be something like a general seat. Okay, and names. Okay, these are the names. We'll do this name extraction later. Okay, and this is the male or female, and age, siblings, this stands for siblings, and this is parent, children, ticket, fare, cabin, and embarked. Embarked is where the travelers mounted from. Okay, it's like starting place or something like that. Okay, I have, yes, train dot describe all. So here, okay, I'll show you that later. So let's start the analysis, guys. So train dot columns gives us the columns. Okay, so in train data we have so many columns. Sample 5, you can either use sample 5 or train dot head. Okay, head gives you around 5 to 10. You can put the values here how much ever you want. Okay, so this is the sample. Maybe this is random sample. Okay, sample gives you random, head gives you top 5 or top 10. Okay, so here numeric values are these many and non-numeric values are these. Okay, this one and this one should be converted to numerical values because our computer or system understands only numeric values. Okay, it doesn't take the non-numeric values, alphabets, and converts it automatically. We should convert it to numeric values and then we could run it through the algorithm. Okay, survive in integers, string is non-numeric, integers is numeric. Okay, so train data, see. So here we can see that these are the observations we have got. Okay, 891 passengers. So we have the data set of 899 peoples in the training set. Okay, test will be having some more data sets, which the test will be having data sets with the predicted values. See, this is already predicted values. Okay, see, we have the survived thing. Okay, so we need to know who survived and who did not survive. So we are just using survived as the final final target value, and all these things are the training values. Okay, so is null checks for the null values. Yeah, see, as we have seen here, this is just an approximation. Okay, it's not the actual values. This is also not the actual values. Just you can see here and you can guess, right? Out of 10, 3 is not missing, almost 30%, something like that. Okay, fine. This is 177 people age is missing and cabin. Okay, so this is missing. I think the majority of the people have gone in one cabin, so that's why it's missing. So we'll correct it later. Okay, 2 data is missing in embark. Okay, age. Okay, fine. Okay, so this is what we are gonna do today. Okay, so in sex, when it comes to gender, females are more likely to survive. I don't know why the females have survived more. Maybe the captain has ordered the people to rescue females first. Okay, and siblings who are alone are more likely to survive, and young children are more likely to survive, and people with higher status are more likely to survive. Maybe they gave money and escaped with the lifeboats. Don't know. Maybe they got the information first. Okay, let's see the visualization thing. So the fourth step we are doing is visualization. Okay, and bar plot, we are using bar plot here. This is x-axis and this is y-axis. Okay, so you can see x-axis contains 6 and y-axis contains survived, and we are using data as train data. Okay, this is SNS seaborne. Okay, wow, you can see here male survived less, females more than double. Okay, double would come somewhere here. It's more than double, 3 times. Wow. Fine. So let's see past class. So here we can see this. Okay, it's for me it's coming dual because the run is I've used dual run methods. First class people have survived more compared to third class people. Maybe the general class people were ignored, and then the first class people were saved because they're very useful for the country, or maybe they had a lot of money at that time. They gave to a captain or something like that. So features. So this is, I think, for siblings. Okay, you can see here these three values. Actually, for you it will only display these three. For me it's displaying an extra three values. I should just correct it with the kernel, but now as I've started recording, it doesn't matter, right? I can show you. So we can see that people with one siblings are more who have survived. Okay, yeah, yellow color one, yellow or dark orange. People with 1 and 2 siblings have survived more than 0 and 3, 4. Okay, so people who had 1 or 2, maybe they have survived with the child, or the family is being rescued first or something. Okay, number of parents and child. This, people with less than 4 siblings have survived more, and more than 0. 1 to 3 siblings have survived more. You can see this. So people with 5 siblings have survived, but 4 and 6 siblings, I don't think so they're there. Even though they're there, I think they would have come down, the graph would have gone down, definitely. Okay, let's see the age factor. Okay, so here you can see that babies are more likely to survive. Okay, they have saved babies more because they are the future. Babies and teenagers, maybe teenagers were quick enough to get through the water to the lifeboats, or maybe they were very rough and they were hurrying or something. They have done it first. Babies and teenagers. Adults have managed to do it, and seniors, I think seniors almost many have not survived. Okay, this is cabin. Where in the cabin has survived more. So let's clean the data. Okay, so this gives us all the thing after. Okay, see there are many null values. Okay, NaN is a null value. So let's fill the null values. So we don't need the cabin this thing right now, or column, and even ticket column we don't need right now. Embark feature, we are renaming these things. Okay, we are giving a name to these things. Okay, so here you can observe that fill now. This one fills every embark null statement with an S. Here, yes, we have named this as yes, right? So the majority of the number, see in these three, don't consider the other three, these three, the majority of the numbers are from S compartment. Okay, S compartment is S starting point. So we will give the other data which is missing as S. Maybe they might be, or 90% of the people might, unknown data might come from S only. So we'll just replace it with S. Okay. So this is next missing values. Okay, so these are all the missing values. All right. So here we are extracting this thing. Name. See, these are the first name of people. Okay. So this one, I think it's very confusing. So let's change and rename this. Okay. Yeah, we have renamed this using this code. We have renamed all these things to Royal, and we have renamed Millie to Miss and Miss. You know, we can observe here, right? We can easily categorize all these things. Okay, so here see, yeah, this is good. So Royals have survived more. Nice. Okay, so here, you know what we are doing is we are converting the numeric data, the non-numeric data to numeric data, because as I told earlier, we need numeric data to do calculations. Yeah, this is converting of non-numeric to numeric. You know, usually we do one-at encoding, which with a lot of dummy variable creations, and also eliminating the first row, which gives us more less time for execution. So here we'll fill the missing values of fair. Okay, fine. So these still here we have converted all the non-numeric to numeric, and we have brought everything into a form where the machine is ready to understand it. Okay, now the main part comes from here, choosing the best model for our prediction. Okay, so this one we have used target and predictors, and test size 0.22 means 22% of the data will be the test data, and other 78% will be the training data. Okay, random state 0, random can be anything. So here let's run this. So these are the algorithms we are using. These are the classification algorithms. Okay, or something like binary algorithms which predicts yes or no. Okay, yeah, as I have told, here we have given 22.22%, but then usually they give 20, 80 or 30, 70. We can go with this one right now. It's a good thing. If the training data is more, we get good accuracy. Okay, here we get 78%. So these are all you don't have to learn all this thing, but you have to learn the back end of these things, how this works, how the formula works, and all those things. It's a beautiful thing. I'll be explaining to you in the later videos all these things in detail. Okay, so just get to know, you know, you don't just run the model, just get to know about this, and then you can do it later. Okay, so let's run all the models. So we are importing every model from sklearn, sklearn.tree, decision tree, and symbol methods, neighbor. Okay, good. Now let's see all the models. Let's merge all the models and let's see this thing. Yeah, so here we have merged all the models, and our percentage of the model is compared here. So the highest percentage is displayed here, 84.77% correct. Okay, this can exactly predict 84.77% whether the person will survive or not survive. Okay, KNN is the least, but 77. Okay, fine. It's okay. 84.77 is a right fit model. Okay. And then this is the submission. Don't worry about this, guys. This is not something which you can worry. This is a lot of things. Actually, after this step, there is something called deployment. With this gradient boosting classifier, we are going to deploy the model and make it into a website or an application, or deploy it into a cloud, or use it for other purposes. So here the last you can find my data set. Usually I'll give it in my GitHub. You can even find it in Kaggle here, and this is my LinkedIn profile, guys. If you have anything, please give me feedback. And yeah, please don't forget to like and subscribe for more videos. I know I should upgrade a lot. I will definitely for you guys. Thank you.